Okay, so we're finishing up on chapter 12. We were almost done with finding vertex of a parabola, putting it in standard form when it wasn't in standard form. And then at the end of last class, I was giving you another way to find the vertex where you didn't have to go through and put it in vertex form if it hadn't already been so. And so let's go through and look at that real quick. And let's look at an example. So this is 12 point, nope, not 12. We're still in 11. So I believe this is 11.6. Okay. And I don't have my 11 notes right in front of me, so I'm just going to grab it. Okay. So if you have an equation, y is equal to ax squared plus bx plus c, we're going to say a doesn't equal to 0, because if it did, again, it wouldn't be a quadratic equation. It would then now be a linear equation, because x squared would go away. The vertex can be found so when you're finding the vertex, you're looking at, I want to say negative b over 2a, comma, and then you're going to go in. If this was instead called f of x instead of y, which means the same thing, just in function notation, if you go in and wherever you see an x in this equation, you replace it with what you found to be our x value of the vertex, negative b over 2a, that will give us the y value, right? So if you had an x value, let's say 2, you could figure out what the y value was by plugging in that 2 wherever you saw an x. So that's what you're doing to find the vertex. The other way that we had saw it was that f of x was equal to a times x minus h quantity squared plus k. If it was in this form, then we could say that the vertex was at hk. Okay, so let's look at an example where it's not in vertex form, where it's given to us in standard form, and say f of x is equal to negative 2x squared minus 5x plus 3. So looking at that, and if it asked me to find the vertex, I would kind of cringe if I was asked to put that in vertex form and by completing the square, just because I noticed that that negative 2, that number I need to make a 1 in front of the x squared, if I pulled it out of the negative 5x, well, negative 2 doesn't go in there evenly, so I notice I'm going to have fractions and then dividing by 2 and squaring. I'm just going to deal with a lot of ugly fractions, which I don't like to deal with if I don't have to. And so I would looking at this vertex form. And so I need to figure out what b is and what a is so that I can figure out what my formula is. So looking at this, I know that a is negative 2. I can see that b is negative 5. I see c is 3, but I don't need that for the vertex formula. And so h is equal to negative b again over 2a. And so let's go back in and plug in those values that we found. And so we get negative b, which is negative 5, all over 2 times a. And a we saw was negative 2. So cleaning it up a little bit, negative times negative, that gives that a positive 5 in the numerator. And I have 2 times negative 2, so that's negative 4. So this is the same thing as -5/4. I'm going to keep it like that. I'm not going to rewrite it as a mixed number for now, because if I did that and then had to put a mixed number back into the value for x, I would actually have to change it into an improper fraction to do that, or a decimal. So we're going to now go and figure out what k is. And so k was equal to plugging that value, -b/2a, in wherever you saw an x in your equation. And so we're going to go in and we're going to plug in -5/4. Wherever we see an x in our equation. And so we're doing that, we have -2. I see x, so plugging in -5/4, that quantity squared, -2. I see an x, so we're going to replace it with -5/4 plus 3. Okay, so using order of operations to simplify, I know exponents come first because nothing in the parentheses can be simplified. And so -5/4 times -5/4, or squaring the numerator and squaring the denominator. I get 25 all over 16. Let's distribute. So this is like -5/1. We don't need a common denominator when multiplying fractions. Just multiply across in the numerator and denominator. So negative times negative is plus. 5 times 5 is 25. All over 4. I'm going to leave a little space there because I know I'm going to have to combine, well, yeah, I know I'm going to have to combine these, and I would like to have space to get a common denominator. So, and then I'm going to bring down my plus 3. So let's simplify. Well, 2 goes, this -2 and the 16 in the denominator. So we can simplify. 2 goes into itself once, and 2 goes into 16 8 times. So I notice I'm going to need a common denominator to combine all 3 of these terms with 8. So my LCD here is 8. So let's go in and get a common denominator of 8 for our other terms. And so I know notice I need to multiply 4 by 2 to get the 8 there. I'm just multiplying by a fancy 1. So multiply the numerator by 2 also. And to get an 8 in the denominator for 3, I'm going to have to multiply by 8 over 8. Okay, so simplifying, I'm left with -1 times 25, which is -25. It's all going to go over our LCD that we just got of 8, plus 25 times 2, so plus 50, plus 3 times 8, which is 24. I can't just simplify the 8 and the 24. I have to do order of operations, so I need to first sum all these up and see if there's a common factor. So -25 plus 50, I know is 25, and 25 plus 24 is 49. So I have 49 all over 8. So I noticed there's no common factors of 49 and 8, and so that's simplified as far as possible as an irrational number. And so this is our k value. So looking at this, I know my vertex is at hk. We just found that h above was -5/4. And we just found plugging in -5/4 wherever we saw an x in our original function, we got 49/8. If I had to go and graph this, to me, it makes more sense to have that as a mixed number or as a decimal form. And so -5/4, well, 4 goes into 5 once. So this will be -1, and I'd have a remainder of 1. So this is -1 and 1/4. 8 goes into 49. Well, 8 times 6, right, is 48. And so it goes in 6 times with a remainder of 1. So 1/8. So could you tell me, is the vertex a max or a minimum value y? So if we went into graph this equation, if we went to go graph this equation, would it be facing up or down? And how do you know? So remember, it's the number in front of the x squared term. So it's our a value. So notice a is -2 here. And it depends on if that a value was positive or negative. And so our value a was -2. So if our parabola, if a is negative, then our parabola faced downwards. And so because our parabola faces downwards, we know that our vertex then has to be a maximum value, maximum point. So some of the homework or problems from this section goes through like maximizing or minimizing. And so it might say you're looking at a ball being thrown up in the air and it comes up, it's going to reach a point and then it's going to start coming back down. And so you might be asked to find the maximum height of the ball. And so if you're doing that, you'll notice that all of these problems in this section are quadratic equations. So to maximize, to find where that maximum height is, you're going to have to find the vertex. The y value is the height, that x value in that case would be time, how long it took for it to reach that maximum height. You might see some examples like you want to build a garden and you want to maximize the area of that garden. And so given the dimensions, or what dimensions would you need in order to maximize that area of your vegetable garden or garden? And so again, when you look at that equation, you'll notice that it's a quadratic equation. If you want to maximize it, maximizing the area, you're going to find the values that give you your vertex. Other direction, a time where you might want to minimize something is when you're looking at costs of something. So if you're trying to minimize a cost of something, you would you'll notice again it's a quadratic equation, and to minimize that cost, and you'll notice that that quadratic equation is facing upward. To minimize that cost, you would look at the vertex. Okay, so finding the vertex is kind of really important. It's an important point on our parabola a lot of times. It gives us some important information about what's going on in real life situations. So after going in more detail about that, let's look at our vertex, and we know that it is maximum point. We could probably tell if it's going to cross the x-axis or not without even solving our equation for when y is 0. So remember, if we found where our vertex was on the graph and we knew what direction it faced, we could tell if it was going to cross the x-axis or not. And so if we plotted the point -1/4 and 6 1/8, so this would be up here in the second quadrant. So to the left 1 and then up 6 1/8. So I'm just going to say this is 6 1/8. We also said that the parabola faced downwards. So going down and the vertex being where it is, it's going to have to cross the x-axis. So we would find some real numbers when we set y equal to 0 and solve for x. What if it said put f of x, our equation, -2x squared, I believe it was +3, right? Nope, minus 5x plus 3. In vertex form. So we just did all that work and we found that vertex. And again, I just said, if there was I would not want to put this in vertex form, especially by completing this square. But lo and behold, there's another way we can do it without completing the square. So notice that vertex form, again, is y is equal to, a times x minus h, quantity squared plus k. We know what a is just by looking at our equation. We can say in our equation, a is equal to -2. We also know what h is. We found it above. We saw that h was -5/4. We also know what k is because we found it, and I'm going to leave it as fraction, in proper fraction form, so 49/8. So all we have to do now is go in and replace what we found and what we know in for a, h, and k. And then it's in vertex form without having to go through and complete the square. So doing that, I get f of x, or y, is equal to a, which is -2, all times the quantity, x minus h, which is -5/4, quantity squared, plus k, which is 49/8. So we get f of x is equal to -2 all times x plus, because minus a negative, is 5/4, quantity squared, plus 49/8. So pretty darn cool. So just to get a little more practice, let's just go back and let's show, and you can then decide which way you would prefer. I don't think I'm going to ask you on this next exam in particular to complete the square to get in certain forms. You might have to do it anyways, but you might not. You might be able to work around it and do things like we just did here. But let's look at that same example and let's put it in this form and show it's the same thing by completing the square. So let's show. We get f of x equals -2 all times x plus 5/4, quantity squared, plus 49/8. If we complete the square on f of x is equal to -2x squared plus 5x plus 3. Okay, so again, to complete the square, our value in front of the x squared has to be 1. And we can do that by factoring that number out of, and we just do it with the x terms. And so we're going to factor -2. Out of -2x squared and 5x. So doing that, we get f of x is equal to -2 times the quantity. Well, I pulled a -2 out of the -2x squared, so I'm just left with an x squared. I'm pulling a -2 out of a positive 5x, so I'm going to have to change the sign to make this minus. 2 doesn't go into 5 evenly, so if that's the case, just put your b value over the number that you pulled out, except for the sign in this case. So if I pulled out, or if I pulled out a -2, then I would be left with -5/2 x here. And you can check it, right? If I distribute -2 times this -5/2, the 2's would cancel. Negative and negative would make positive, and I would be left with 5x, which I wanted. Then I left a little bit of room in here because we were going to add something. The whole point of this was so I can complete the square. We were going to add something inside the parentheses. But if we added something to one side of the equation to make it equivalent, we had to subtract it. On the same side of the equation, or we could have added it to the other side, but I didn't want to do that. So +3. So f of x is equal to -2 all times something squared. So thinking of what is this number that we are adding to itself to get -5/2. Whatever that number is, we want to square it to put it here.
I was just wondering, is it supposed to be -5x? Or are you trying to do the same problem as we did originally?
Yeah, was that a negative in there?
Yeah, it was a -2x squared minus 5x plus 3 is what I have.
Okay, sorry. So just let's change this a little bit. So this right here, thanks for catching that, or we wouldn't have gotten the same thing at the end. This should be a minus right in here. Okay, so because that's a minus, that changes this to a -5x that we're trying to get when we pull out -2, which changes my sign then, because if I pull a negative out of a negative, that would make this a positive. So remember, you look at your b value once you are trying to complete the square and got it in the form that you could. Take that b value and divide it by 2. So 5/2 divided by 2 is 5/2 times 1/2 is 5/4. And if we square 5/4, 5/4 times 5/4 is 25/16. So the same number you multiply to get 25/16 is 5/4. So 5/4 times 5/4 is 25/16. 5/4 plus 5/4 is 10/8, which reduces to 5/2. So that's what we wanted. This is where I said that this is a little bit tricky because really we didn't add 25/16 on this side of the equation because of the -2 out here. In order to drop that parentheses, that -2 has to be distributed to every item. And so technically we added on this side 25/16 times -2. So let me just write that. So we really added -2 times 25/16. And so if I reduce that and just 2 goes into itself once, 2 goes into 16 8 times. And so we really added -25/8 to this side of the equation. So to get undo, if I'm doing it to the same side, I want to really add 25/8. So we need to add 25/8. So it is like adding 0.
I can't see that. I don't know if
Were you guys, did you see it until now?
no, I guess my where I see all of you guys is blocking it?
Yeah, press the dash, like the first little dash, and they'll go away for a minute. That way you can see what she
Oh, thank you.
Yeah.
Awesome, thank you.
All right, I'm gonna mute myself now.
Okay. Okay, so really we're undoing what we're adding to the one side, so it's similar to adding 0 to the one side. We're just adding 0 to kind of manipulate it how we want to get it. So technically we added 25/8 to cancel out the negative 25/8 we added on that one side. And now I need to combine my 25/8 out here with my 3. And so if I think I need to combine them, I need a common denominator. And so if I multiply my 3 by 8/8 to get that common denominator, that would give me my plus 25/8 plus 24/8. So this is equal to -2 all times x plus 5/4 quantity squared plus, well, 25 plus 24 is 49 all over 8. Which is the same thing we got above. Just want to make my box a little bigger. So again, it's really up to you and the method that you prefer, but either way, you can either use that vertex formula, the negative b over 2a to get the x value, plug it in wherever you see an x in the original equation to get the y value, and then go just plug it in for h and k for your vertex form and your a value that you should notice what it is from the original equation. Or you can go through the method of completing the square to get the same thing. Let's just see. Maybe just do one problem, a one word problem. Okay, so we're given that the length and width of a rectangle must have the sum of 94 feet. Okay, so the length and width of a rectangle must sum to 94 feet. Before I even write any more about what the problem says, let's even just write out what that says. That's not too bad, right? The length and the width of a rectangle must sum to 94 feet. So that means that the length plus the width, the sum, addition, must equal 94. Okay, so we know a little piece of our information, so let's go further. So find the dimensions of the rectangle whose area is the largest possible. So find the dimensions of the rectangle. That makes the area the largest possible. Okay, so it's asking about area. And so think to yourself, what do you know about an area of a rectangle? Well, area of a rectangle is just the length times the width. So I actually have two equations. This is what I'm trying to maximize. So what value is that maximum area? The problem is I don't want length and width. I don't want both variables in here. I just want one variable. I either want just both in terms of length or both in terms of width. And we can do that by using this information. So either solve for your length and get that by itself, or either solve for your width and get that variable by itself. It really doesn't matter in here, and one's not easier than the other. So again, it doesn't really matter. Either way, you get the same result at the end. And so let's say that length then is equal to, so all I'm doing is subtracting width on both sides of my equation, and I would get 94 minus W. So I know my length is equal to 94 minus W. And so instead of writing my area now as length times width, my length I'm going to rewrite as 94 minus W.
Could you have done it the opposite way?
Yeah, so
Okay.
I could have done width is equal to 94 minus L. And at the end, we would still get the same thing. Instead, this would have L's in it instead of W when you replaced it. And so looking at that, let's just distribute our W and rewrite it so that the W squared piece is first. And so when I distribute my W inside the parentheses, I get 94W minus W squared. So I'm just going to write it as negative W squared plus 94W. Just rewriting the order because normally we see the square piece first. So look at this. Notice what your A value is. A is -1, the number in front of the W squared. If that is less than 0, right, it tells us our parabola faces downwards, which means we know our maximum going to occur at the vertex. So basically, I'm just going to find the vertex of this equation. And so if I look at this, and I determine what my A value is and what my B value is. So in this case, A is equal to -1, and B is equal to 94. So the X value, which is, we call it H, of the vertex is -B over 2A. So if we plug those values in, I get negative times B, which is 94, all over 2 times A, which is -1. So this would give me -94 all over -2, which is positive 47. So our case, we're not using X. And so this is actually what variable is a 47 representing? Is that representing our length or our width there? What do you think? So what should we let be 47 feet? Well, usually that's an X value. Other one.
Oh, width. Okay. That was my first guess.
Yeah, width, because we had written our equation in terms of W. if I had rewritten this and had solved for W instead and had this in terms of L, that would be my length. So remember when you're doing, when we were looking at it before, we were having equations with X instead. Let me just go here. And when we were looking at the vertex, the H value was the X value of the vertex. So in this case, because our equation is in terms of W, that is going to be what that value is. W is going to be 47. So find L. Well, we said L was equal to 94 minus W. So 94 minus 47. I was thinking about this when you said it. Technically, your number is the same. So 47 is also your length, but it's because of this equation. Okay, so we can maximize area of the rectangle by choosing a length and width of 47 feet. What if the question went a little further and asked you, what is the maximum area? I want to call it garden, but I didn't call it that really at the original. So what is the maximum area of the rectangle?
You mean by choosing 47 feet?
I was wondering too, of 42. I was a little confused.
Oh, sorry.
Okay.
I don't know where I got 42 from. I like that number better than 47. I don't know why. 47. Thank you. Just making sure you guys are awake out there. You are paying attention. Make me happy. So any ideas on how you would find that maximum area then? How do we find area?
The length times the width.
Right, and so we found the dimensions of the length and the width that made it the maximum area. So to figure out what that area is.
Oh, I was going to say add them together.
Well, would it be 2,209?
Is that 47? Is that what 47 times 47 is?
Yeah.
So you said 2,000, what?
209.
249?
2,209.
Okay, thank you.
209.
Don't forget that this is square feet.
Oh.
So I might have knocked off a half a point there. No, not out of a 1 point. I had to kind of figure out my grading system, because I normally don't allow things to be just 1 point. And so when I was giving partial credit, I had to think about that. Anyways, so we found the maximum area and we found the dimensions that would give us that maximum area. So pretty cool. So that is 11.6. So just kind of a recap of 11.6, everything we've done. We saw different methods of solving quadratic equations, factoring quadratic formula, completing the square, square root method. And then we looked at equations that we can manipulate to look like quadratic equations so we could solve them. We solved radical equations. What else? And then we did all the graphing of these quadratics. And so now we just so you know what we get to jump into next. We're going to look at functions, operations of functions. So stuff that you've already done. So how do I multiply 2x plus 1 times 5x plus 3? Just kind of giving you a different notation of how you might be seeing that written. We're going to look at inverse functions, composition of functions, and then we're going to start getting into exponential equation and logarithmic equations, graphing and solving. So that's all of chapter 12. So before we jump into 12, let's take a little bit of a break. So I'm going to pause the video for a second. Okay, so we're now getting into 12.1, algebra functions. And so these are things that you have been doing. It's just different notation that you might notice or are seeing right now. But operations of functions. So let's say that f of x and g of x are functions. The following notation holds. So if you have a parentheses, f, it could be plus or minus in here. I'm just going to do it, both of them, so I don't have to write it twice. Plus a function g, or f minus a function g, and then with your x out here. This is saying f of x plus or minus the function of g of x. Okay, I just want you to be careful. This does not say, this is not x times. F and x times g. This is just adding or subtracting both functions together. Okay, so it's just notation, but it kind of looks like the distributive property there. So I just wanted you just to be aware that that's not what that's saying. That's just saying that you're adding some equation that you were given for f of x to some equation you were given to g of x, or taking f of x and subtracting off the whole equation g of x. Another thing I want you to be careful of is when you have subtracting off that function g of x, you need to carry that negative to each term, distribute it before you start combining like terms. But we'll look at an example of that in a minute. Other notations, so if it's telling you that you're going to divide your function f of x and g of x, it would be written as parentheses. Looks like an f in the numerator and a g in the denominator, and then parentheses with an x. So this is just saying f of x all over g of x. Because I have g of x in the denominator, I need to put a little stipulation there that g of x cannot equal 0. I can't have a division by 0, and so I have to make sure that that's not happening. And then the last one, I might have said I was going to do that before, is f times g. So parentheses f dot g of x. This is just saying I'm taking my equation f of x and then I'm multiplying it to my equation of g of x. Be careful in a minute or before we finish today. We're going to look at compositions of functions, and that looks very similar to multiplication. So let me just put that there now. So if I had something that looked like f, and then in between, there's a little teeny circle, g, parentheses of x. This is basically telling me I'm looking at my function f of x. I'm going to write it in a different way, which means the same thing. And then wherever I see an x and f of x, I'm replacing it with my function g of x. So this is a composition of two functions. And again, we'll come back and talk about this, but you're replacing any x in the equation of f of x. Wait, so like replacing any x in the equation of f of x with the equation of g of x. Okay, so let's look at an example. Let's say you were given two equations. One of them was f of x. And let's say f of x is 2x squared minus x. And let's say g of x is given to be 3 minus 5x. And so part A asks you to find f minus g of x. So this is saying I'm looking at my equation f of x minus whatever my equation g of x is. So all I'm doing is I'm going to go back and rewrite it. So instead of writing f of x, I know f of x is the same thing as 2x squared minus x. So I'm going to rewrite that, 2x squared minus x minus, so be careful, I need to put parentheses around that whole equation of g of x. And g of x is 3 minus 5x. So distribute our negative. So we still have the 2x squared minus x out in front. Distributing the negative, so negative 1 times 3, so that's minus 3, and negative 1 times negative 5x, so that gives us plus 5x. We want to combine like terms if there are any. I don't have any other terms with x squared besides the 2x squared, so bring it down. I have a negative x plus a 5x, so that gives me a plus 4x, and then minus 3. Okay, so you are done at this point. So a lot of times students will want to go further and now start factoring it or trying to solve for x when that's 0. And that's not what the question said. It just wants you to find when f of x or f minus g of x. So basically all we're working with are basically expressions. And simplifying them using the operation it's telling us. So if it had said, find f times g of x. So this is just telling me I'm taking my equation of f of x and I'm multiplying it to my equation of g of x. So this is equal to the 2x squared minus 2x, all times g of x, which was the 3 minus 5x.
Just x,
Oops.
right?
You're right. Just
Okay.
so f of x is 2x squared minus 2. It's bizarre because I was just thinking about me making an error and copying things down, right?
It's an x, I thought.
Wait.
Minus 2x squared minus x?
Oh yeah, that's what you meant. Okay, so minus x. There we go. Okay, so just distribute. So this is not too bad. This stuff is just different notation. You might have seen it written before, but it's all stuff that you have been doing. So 2x squared times 3, and so that gives me 6x squared. 2x squared times 5x, so that's minus 10x cubed. Now distribute your negative x, so negative x times 3 is minus 3x, and negative x times negative 5x, that's positive 5x squared. So rewriting it and combining like terms, I have a negative 10x cubed, I have a 6x squared plus a 5x squared, that gives me 11x squared, and then I have a minus 3x. So what if it was saying the same thing, but instead of the x, there was a negative 2 there? So what would we do in this case? Any ideas?
Would you still be multiplying the negative 2? Yeah, would you distribute it to the f of x and g of x?
So kind of the same idea here as before, like this x is not being distributive. It's just like a property of the function. And so this number here is just representing that you're going to do what we had been doing before. Like if you saw f of negative 2, so this is saying, and one way we can think of it, there's two ways we can do this. We can look at f of negative 2 all times g of negative 2. So f of negative 2, basically all that's telling me to do is plug in negative 2 where you see an x and f of x. And g of x. Then multiply. The results.
I think that I said it wrong. I was meaning that, like you times the negative 2 by the 2x squared minus x?
No, so that's where you're going to go in wherever you see an x in this equation. You're going to replace it with this negative 2. And so this is going to give me that 2 times, I see an x there. So I'm going to replace it with negative 2. And then I have to square it. Oops. Minus, I see an x there, so I have to replace it with a -2. I did these kind of wrong, opposite colors. All times g of x, g of -2. So now I have to go in wherever I see an x in f of x, I'm sorry, g of x, I need to plug in -2. So I have 3 times -5 times -2. And then in my parentheses. So I kind of have to do order of operations to simplify, work inside the parentheses first. Exponents go first. And so we have 2 all times, well, -2 quantity squared, that's +4. And a minus a -2 is really +2. I have to do multiplication before I subtract. And so I have 3, and then I have -5 times -2. So this is really 3 plus 10. So 2 times 4 is 8. 8 plus 2 is 10. So I get 10 in the first parentheses. 3 plus 10 is 13. And if I multiply that out, I get 130. That's one way that you guys can do it. Or you already did the work above. Let's see if I can pull this. Oops. Let's try that one more time. Oops. Okay, so instead of going back to the original functions and plugging it in, oh no. Darn it. Let's just leave it there. So let's plug in f times g of -2. Let's show we would have gotten the same thing that we got above, 130. So we could have just gone to the function where we looked at f of x times g of x, and then go in, and wherever we see an x, we can replace it with a -2. So we have -10, parentheses, you're going to place x with -2, cube it, plus 11. Replace x with -2, you're going to square that, -3 times, replace x with -2. So order of operations, exponents first. So we get -10 all times -2 times -2 times -2. Cubing -2 gives you -8 plus 11. Squaring -2 gives us +4. And then -3 times -2, so +6. So we get 80 plus 44 plus 6. So combining 80 plus 44, that's 124, plus 6 is 130. So basically, f of some value, -2 times g of -2 is the same thing as f times g of -2. And again, you don't want to think of that as the distributive property. You want to think that is the function when x is equal to -2 when you're multiplying. Okay, so let's look at it with a composition. So let's say, and let me just rewrite it again. So f of x was equal to 2x squared minus x. And if g of x is equal to 3 minus 5x, what if it said find f little circle g of x? Okay, so this notation means the same thing, and I like this notation better, of f parentheses g of x. So basically, g of x, oops, I don't want that. We're replacing that right in here. So I get f of, well, g of x is 3 minus x. I'm sorry, 3 minus 5x. Parentheses. So that's telling me, instead of plugging in a number like we were doing before with -2, I'm going to replace x and f of x with this whole 3 minus 5x. So let's just go through and put parentheses where x is. So I have 2, I see x, I'm going to put a parentheses there and enough room to write that whole expression. Quantity squared minus, I see a x there, so I'm going to put parentheses so I can go back and replace x with that whole expression. So this is 2 times 3 minus 5x quantity squared minus parentheses 3 minus 5x. So let's simplify. Order of operations, I can't just square the 3 and just square that -5x. And if you do that, you'll make your instructor very sad. That is telling us we're taking that parentheses, 3 minus 5x, and multiplying it by itself twice. So this is 3 minus 5x times 3 minus 5x. Don't forget to bring that 2 down. Also, I can't just drop these parentheses, second parentheses. That negative has to be distributed to each term. And so this would give me -3 plus 5x. I'm going to distribute my 3 minus 5x times 3 minus 5x before I distribute my 2. And so doing that, I get 3 times 3 is 9. 3 times -5x is -15x. Distribute -5x. -5x times 3 is -15x. And -5x times -5x is plus 25x squared. Close my bracket, bring down my -3 plus 5x. Okay, so I have 2 times 9. Let's just distribute. I know I can simplify inside, but I want to save some time. So let's just distribute. 2 times 9 is 18. 2 times -15x is -30x. 2 times -15x is -30x. 2 times 25x squared is plus 50x squared. Bring down my -3, I'm sorry, my -3 and my positive 5x. Combine like terms, I only have one with a x squared, so bring that down, I have 50x squared. But combining, I have a -30x minus 30x plus 5x. So that gives me a positive, that should be 50x squared. And that gives me a negative 55x. And then constants. If I look at this, oh, I want to change my color. I have negative 3 minus or plus 18. So that's going to give me a positive 15. Okay, so we're done. It's not asking me again to factor this. It's not asking me to solve for x. It was just asking me to take the composition of the two functions. What if it instead, it didn't say f of g of x, the composition of those two. It says g, little circle, f, in parentheses of x. So this is saying take the composition of g of f of x. So another way to write it is g, and then parentheses, the equation f of x. So if we went back and we looked at our equation of f of x, we saw that that was, where'd it go? There it is, 2x squared minus x. And g of x was 3 minus 5x. So really what this is saying is instead, we're going into our equation of g of x, and wherever we see an x there, we're replacing it with f of x, which is that expression 2x squared minus x. So this is equal to, so let's just go through the equation of g of x and put parentheses where we see any x. So we have 3 minus 5. So we see an x there, we're going to put parentheses because we're going to go back, and now we're going to replace that with 2x squared minus x. And so we can simplify a little bit by distributing our negative 5 inside that parentheses. Let's bring down the 3. So negative 5 times 2x squared is negative 10x squared. And negative 5 times negative x, so that gives me plus 5x. So this is equal to, just rewriting it, descending order of powers is negative 10x squared plus 5x plus 3. So notice composition, order matters. So notice the one above, when we looked at f of g of x, is not the same as if we got g of f of x. And usually that's the case unless they're special functions, which are normally inverse functions of one another, but you're going to have to wait for that. So notice order matters. When taking the composition of two functions. So f of g of x normally does not equal g of f of x. It's possible, but in most cases, this is not equal. one more piece. What if it had said,
Are you seeing Erica's questions?
nope,
Okay.
my thing is,
For you.
thank you for, let me pull up, that went away for some reason, the chat box. Oh, there it is. It was hidden by your pictures.
No, Erica, I can't hear you. Are you trying? I only see your messages.
Yeah, I don't hear you, Erica. I see that your microphone is not muted. But maybe something's wrong. But so is that your final answer? Is this final answer up here, the negative 10x squared? Yeah. So that is the final answer. It just wanted the composition. It wasn't asking us to solve it. It was just asking us basically, we're working with an expression, kind of plugging in wherever we see an x, some other equation. So we're not trying to find x here. We're not looking at when is this equation equal to 0. We're not trying to factor anything. So all these, and so that's a common error. Students will like to take things further than they have to do sometimes. And so I would hate for you guys to spend so much time trying to now factor these and setting these equal to 0 and trying to find when that happened, because that's just not what it's asking. If it had instead, like we had done in the other problem, where instead of having that x, it had a number, like we looked at with a -2 in the other problem. So for instance, if it said g, that little circle, yeah, I kind of read it as of. So that g of f of x, if it had been g, let's say, of f of -5. So the couple ways that we can do this. We can just go in, and we already did the work, and plug this in wherever we see an x in the g of f of x. I'm sorry, plug in -5 wherever you see an x in g of f of x. So we just saw that g of f of x was equal to the -10x squared plus 5x plus 3. So this question, if I want to look at g of f of -5, it's telling me I'm going in this equation or expression, and wherever I see an x, I'm going to replace it with -5. So just go through and let's rewrite it, putting in parentheses wherever you see an x. We have -10 parentheses, and then that parentheses is squared, plus 5, you see a x, so put parentheses, and then in parentheses plus 3. So replacing x with -5 and then simplify. So I have -10 times -5 squared. -5 times -5 is positive 25. 5 times -5, so that's -25 plus 3. So I get -250 minus, well, 25 plus 3, that's -22. -25 plus 3. Adding two negatives, so that gives me -272. The other way that we could have thought of this So this is basically saying you're looking at g of f of -5. let's first find what f of negative 5 is. And so recall f of x, that was just the 2x squared minus x. So f of negative 5, we're going to go in wherever we see an x, replace it with negative 5. So first I'm going to write it with parentheses wherever I see an x. So I have 2 parentheses and then that squared minus, I see an x parentheses. Replace or put in negative 5 wherever I had that parentheses. Order of operations. So square my negative 5 first. That's 25. So 2 times 25 minus a negative, so plus 5. So this is equal to 2 times 25 is 50 plus 5, which is 55. So f of negative 5 equals 55. So that gives us g of, well, f of negative 5 we just said was 55. So now we got to go to our equation of g of x. And so now find g of negative 5, or negative, I'm sorry, g of 55. So let's look at our equation of g of x. That was 3 minus 5 times x. So I'm going to put parentheses there because that's where x was. And let's replace x with 55. Order of operations, I need to first multiply before I subtract or add. So negative 5 times 55, so that's minus, let me just do this in my head a little bit. 5 times 5 is 25, carry my 2. 5 times 5 is 25, carrying my 2, so that's 275. Adding a positive and a negative. So I have 275 minus 3 is 272. Larger one was negative, so this is negative 272. Which should be the exact same thing I had gotten before. So there's 2 ways we could do it. We could just go back in. If we had already done the work and found the composition of the function, then we could just go back in and plug it, that number in wherever we saw an x. Or if we hadn't gone through all that work and finding the composition of the 2 functions, we could just go in and plug in the number into our functions and do it that way. See. Okay, let's get a different example. So let's say we had f of x is equal to the square root, and underneath the square root is x minus 2, and g of x we're given is equal to 3x minus 1. So let's look at f of g of x and g of f of x. So order matters. This is telling me I'm taking my equation g of x and replacing it wherever I see an x in f of x. So if I look at my equation of g of x, that is 3x minus 1. So I'm just replacing g of x with what it is. So I want to go in, this is saying I'm going in and I'm replacing wherever I see an x in f of x, I'm going to replace that with this whole expression 3x minus 1. And so I have the square root. You see an x there, let's just put a parentheses because we're going to go back and replace it, and then we have a minus 2. So replace the parentheses with 3x minus 1. I don't really need the parentheses there, and then a minus 2. And so simplifying underneath the radical, I only have one term that has an x, so bring it down, 3x, and then I have negative 1 minus 2 is negative 3. So part B, if it wanted g, find g of f of x. So this is saying we're going to take our equation f of x and plug it in wherever we see an x and g of x. So let's go back and replace in this parentheses what f of x is. So f of x was the square root of x minus 2. And now we're going to go in and we're going to plug that in wherever we see an x and g of x. Well, g of x was 3x minus 1. So let me just rewrite this. This is, you have a 3. Let's put a parentheses wherever we see an x and g of x. So 3, you see an x there, put parentheses. And then we have a minus 1. Right? So go in, plug in your, what f of x is. F of x is square root of x minus 2. Okay, so rules, we cannot multiply underneath this radical with a 3. So we already talked about this from chapter 10 and rules with radicals because this doesn't have a square root. So I'm just going to leave it as 3 square root x minus 2 underneath the radical. And then outside of the radical, a minus 1. And so the composition in the other direction is not the same as a composition in this direction. Okay. So that's pretty much everything from 12.1 except for one quick thing. I'm just going to give you a quick example so you can't come back and say I didn't do one. Basically, we want to work backwards. You're given h of x. So you're given some function and you want to rewrite it as a composition of two functions. And so let's say that you were given that h of x is equal to 2x minus 3 quantity squared, oops, minus parentheses 2x minus 3 plus 1. And we want to find an equation of f of x and g of x. Such that h of x, this equation up here, would be the same thing as if we took the composition of f of g of x. Okay, so the trick on this is see if there's anything repeating itself. There's multiple, a lot of times there's multiple ways that we can do these and there could be different answers. But look at what's repeating itself. So if I look at my equation of h of x, I notice that what's repeating itself in here is that parentheses 2x minus 3. So if I treat my inner function to be what is repeating itself, so let's choose g of x. To equal the 2x minus 3. If that was the case, then f of x, all I'm going to do is wherever I highlighted in yellow, I'm going to replace that with x because I want to replace that whole expression 2x minus 3 and wherever I see an x in f of x. So if I do that, then I have x squared minus, I see an x, or that yellow, and then plus 1. So we found two functions such that if we took the composition, and let's just show it. So doing this, this is giving me f of g of x, which we had chosen to be the 2x minus 3. We're going to go into this equation right here, and wherever we see an x, we're going to replace it with this 2x minus 3. And so doing that, we get x, which is 2x minus 3, quantity squared minus x, which is 2x minus 3, and then the plus 1, which was what our original function of h of x was. Okay. So I know I quickly went through that last example. I could spend a little more time on the end of chapter 11 than I wanted to, but I really wanted to get through that, so I can say we got through 2 sections this week. So let me pause the video. So homework that's going to be due on my math lab. I believe I extended some of your dates, and so we covered this week. We covered 11.6 and 12.1. and a little bit of 12.5 at the end. So I believe I moved last week's homework to this Monday also. So you might have a bunch of stuff to do if you didn't do the work from last week.